So welcome back to the continuation on the video on the lithium-ion battery pouch cell work that we're doing earlier. So if you haven't watched that one, please kindly watch that one before you watch this to get a better understanding. So we continue by adding our materials. So previously we did add our parameters, we built our geometry, and we did uh add our probes. So we wanted to continue by adding our materials. And to add our materials, you first go to the add material section, and we're going to add a copper and aluminum. So in the built-in, we're going to add a copper. So we've added our copper, and we need to add our aluminum. Okay. And we're going to set up our materials using the battery and fuel cells materials. We go to batteries and fuel cells. And under the electrodes, go to graphite electrodes. We're going to add we have a number of electrodes over here. So I want us to add, we're going to add our negative and our positive electrodes. So this is our positive electrode. This is our negative electrode. So we've added our electrodes, our materials. Now we have to add electrolytes. Now we've added our electrolytes. So after adding our material, electrodes, electrolytes, we're going to assign each of them to where they're supposed to be, respectively. Let me start with yeah, doesn't matter. It can always be there. I wanted to bring doesn't matter. You can still do it. So for Okay, we have copper, aluminum, graphite, electrode, and lithium. Okay, so what you're gonna do is you're gonna assign. So for aluminum, copper, for instance, locate the geometric entity selection, and copper is going to be at the positive current collector in the tab. So from the selection is going to be at the positive current collector in the tab, yeah. And aluminum, for instance, is going to be, sorry, did I say positive? No, it's going to be at the negative. Copper is going to be at the negative current collector and tab, and aluminum is going to be at the positive current collector and tab. And for our graphite electrode, it's also going to be at the negative electrode. Our graphite is the negative electrode, and our is going to be at the positive electrode. Lithium-ion. This positive here, negative. Positive, and we have negative. Our electrolytes is going to be at this separator, as we all know. So we're going to start by adding the separator domain to the battery. And for separator 1, then right click and add the separator domain. So we have the separator added to our lithium-ion battery. And we select the domain to be the separator. We go ahead to select okay. Now we set up the porous electrodes in the current electrodes. Porous electrode. And in the setting window for the porous electrode, we're going to make it known as the negative. And it's going to be the negative electrode. Yeah, we locate the electrolyte properties from the electrode material list, and we want it to be this. That's the flow through this. Okay. Locate the pros matrix properties as well. And under the pros matrix properties, we want to change this volume fractions to this value, which is already named in the parameters. As well this, as well as also named in the parameters. And we move to the particle. We add a particle intercalation. And under it, in the particle intercalation, we look for the particle transport properties over here. And under the RP, change that to RP negative. That's the particle mean center surface distance. We move to the porous electrode reaction. I want to look for the electrode kinetics under this section. And under the reference exchange current density, we want to define it as so we'll add the next porous electrode. This is a porous electrode soon, which definitely is going to be the positive. Because here we chose the negative. Here it's going to be the positive as we've done. And as we did for the electrolyte properties as well. Material 5 as the electrolyte properties. And we move to the porous matrix properties as well. positive, and we have 1 minus positive. And the particle intercalation. So where we locate the particle transport properties and the arrow doesn't mean. Okay. Okay, the exchange current density. You add an electrode. Which will be the metal foil domain. We're gonna add so look for the boundaries and going to add an electric ground to it. Choose a positive tap end, that's the electric ground. Okay, so we've added our electric ground to this. Okay. I want to add an electrode current. So under the electric current, the boundary selection, I'm going to choose the positive end tab. So we choose the electrode current is the positive end tab, and the electric ground is the negative. Sorry, the side should be the negative, so that the side stays as the positive. So that's under the current section. You can put this input there as I. and this will be 4V. So we would add an initial cell charge distribution. Under the battery cell parameters, select the initial cell state of charge and want this to be SOC start, and want this to be KL, that's a cups. So let's expand this initial cell charge and add a negative electrode section. We have to choose a domain for this. So I'm gonna choose the negative current collector. I'm gonna choose a negative current collector electrode. And add a positive electric selection, choose a positive electrode. Okay, so now that we're done, we can move to create a mesh for this. So afterwards, we can check everything to make sure that before we mesh, we check everything to ensure that every area is well defined. If not left any place on 10. So you just keep clicking all these areas as I'm doing, just to have an idea that nothing is, no mistake has been done. And areas which were undefined have now been defined because we've actually done we've defined everything in the physics section. So where we are moving next is just the meshing, and we're going to compute the work. So as I'm doing, please check so that if you've actually made a mistake somewhere, you can easily go back to correct. Okay, so now that you've checked and everything is intact, everything is correct, we can now move to mesh. So with the meshing, we're gonna set up the mesh we're gonna use a mapped mesh for the boundary and a swept mesh for the rest of the geometry. So for the mapped mesh, what you're gonna do is add going to select boundary 20 for this. I'm going to add a swept. Okay. So as you can see, we set so we are good to go for the meshing. I just wanted to check that everything is okay. All I'll do is I'll right click and I'll choose distribution. And in the domain section, I'm going to choose a negative electrode. I'm going to choose the predefined. The number of elements, I'll make the 105. No, let's make that 15. And elements ratio, I'm going to make that 3. I'm going to add another distribution. I'm going to choose a separator. Number of elements. Number of elements, let me just make it 4. And I'm going to add another distribution. I'm going to choose a positive electrode. And here is going to be predefined. The number of elements is going to be 15. And elements ratio is going to be 3. I'm going to select the reverse direction. And I'll build everything, as you can see. This is a finalized mesh, and this is how it's gonna look like. So if you did your mesh and it did not look like this, please go back and kindly check on how I did it systematically. Okay. So this is a finalized meshing, and this is how it's gonna look like. So the next step is I'm gonna do the steady, and we're gonna plot out different results from these work. So I'm gonna do that in the next video. So if you're able to do this to this point, you watch the first and then the second video. I'm gonna do the last part in another video. Okay. So I'll see you in the next video.